So in this lesson, we'll be going over the multiplanar reformatting function of three-dimensional echocardiography. And specifically, we'll be going over this en face 3D view of the mitral valve with color flow Doppler incorporated into it to identify the largest effective regurgitant orifice area in this patient with severe mitral regurgitation, to decide and finalize the clip deployment strategy and identify the clip deployment site. And we'll be using a specific function of this software, that's anatomical landmarks, to go over the specific site. So ideally for this function, you need to have an image with the highest line density and highest frame rate. That is only possible through an R-wave gated acquisition. And as you can see, this specific image has been acquired over 8 beats. Sometimes it is not possible, so you'll have to rely on a single beat acquisition with high volume rates. In this specific patient, as you can see, the MR is significant, and despite upscaling of this Nyquist limit, it is still difficult or nearly impossible to identify the specific site where the effective regurgitant orifice area is the largest, where it would be best to deploy an edge-to-edge repair device. For this specific function, we'll have to activate the flexi slice function, which is the multiplanar reformatting software of this system. So as soon as we click this thing, we get into this environment where we are demonstrating the three-dimensional rendered image with 3 lines across it, which represent the 3 sections of the mitral valve. For example, this section, which demonstrates the mid-esophageal long axis view, essentially demonstrates this yellow section which is going across this portion of the mitral valve. The blue section, as you can see, represents the transverse section, which is essentially going through the mitral valve at this level like now. And then finally, the white section, which is going from medial to lateral in this specific case. And as you can see, if I move this blue line, the line moves on the rendered image from one way or the other. So there are multiple ways of doing this thing. A lot of people like that when they move one slice, the other should move in a perfect orthogonal position with that slice, but I personally like to move each one of them separately because it just gives me a little bit more independence in identifying the section. For example, the first one is to see that the yellow section goes perfectly between AP views of the mitral valve, and I'm going to use this image as my baseline to see that's the aortic valve, that's the mitral valve, and now this image is going through a perfect middle section of the mitral valve. At the same time, I'm going to adjust the white plane to get a perfect medial to lateral orientation, and now you can see that we can have a perfectly laterally oriented white section over here, and it's orthogonal to the blue section. So now we can see that we have the white section going through medial to lateral, going across the line of coaptation, demonstrating the extent of the jet. I can also click on this thing to take off the color flow Doppler information to see that the underlying image is of good quality, and we can see everything over here. Okay, so having said this thing, now we can put the color flow Doppler information back on to see that we are now in. So as you can see, this is the lateral aspect of the coaptation line. This is the medial aspect of the coaptation line. Now, if I'm going to move this, first step would be to stop this thing in a mid-systolic frame when you have the largest effective regurgitant orifice area. You can scroll through this function until you get the largest effective regurgitant orifice area like this. And now you can move this crosshair from this being the A2P2 location to the medial aspect of it. And you can confirm that by looking at this and other sections to see whether you're doing the right thing. So if I move it laterally and the widest part of the jet, now you can see that I am exactly at the widest part of the jet and align the orthogonal planes again to be exactly in the middle of this lateral regurgitation jet. It is important that this is not exactly a transcommissural view, it is actually flipped. So this is P1, A3, and P3 over here, P1, A2, and P3 over here. So this is the lateral aspect of the jet. I'll take off the color flow Doppler information, and lo and behold, you see that there's a large coaptation defect. At this time, I can activate the 4D marker function of this, take the lateral landmark and put it exactly in the middle of this effective regurgent orifice area, and you can see that this is represented in all planes. You can see where the largest effective regurgent orifice area is. I can confirm that again by going over, putting the color flow Doppler information, and you can see you are exactly in the middle of this thing. Now we are going to repeat this function to move this crosshair onto the most medial aspect of the regurgitation jet, again confirming from multiple cross sections that I am in the middle of this jet, and I'm looking at this jet as orthogonally as I possibly can. And then again, I'll take off the color flow information to see, lo and behold, there is a large coaptation defect. Again, going on to the landmark function, I am going to put a medial effective regurgent orifice area, and you can see it is represented faithfully in this rendered image and the other three sections as well. And now, if I was to simply run this thing, now when we are doing the imaging and when we are telling our proceduralists where exactly to go for the placement of the H2H device, now you have a very specific target showing you can go one or the either side. You can confirm this again by putting the color flow information to show that these are the locations of the two largest jets. You can make these thing obvious by taking them off, or making these lines a little bit more obvious by showing that you have correctly identified. And if you take the crosshair onto this one, you can see now you have the lateral effective regurgent orifice area. So I personally think that this is one of the best ways of identifying the effective regurgent orifice areas. It enhances and facilitates communication, and rather than going left or right, you can be very specific in your guidance, and they can know exactly the target zone or where to deploy the clip. Thank you.